Just going to give it a few more minutes to allow people to join. Good morning, everyone. All right. Looks like we're ready to get started. So first of all, thank you everyone for joining us today. My name is Veronica. I am an invasive species coordinator with ISCBC, and I'm really glad that you're all here to join us to learn more about spongy moth and what it could mean for British Columbia. So we have two wonderful speakers today. First, we'll hear from Willem Blackburn. He is a Canadian Forest Service research scientist based at the Pacific Forestry Centre in Victoria. His research focuses on the ecology and genomics of invasive insects that can pose a threat to Canada, but also around the world. This can include ongoing research and collaboration with other organizations such as the USDA, CFIA, and also academic institutions. And this can include research on population genetics and genomics of the flight of spongy moths, but we'll hear more in his presentation. And we also have with us Camille Morales. She is an ISCBC invasive species coordinator. She has been with us since 2023. She's based out of Vancouver and has a Bachelor's of Science and a diploma in Forest and Natural Areas Management. And also, I would like to acknowledge that we're all joining from different places across the province, or maybe beyond the province as well. So we would like to gratefully acknowledge the territories of the Indigenous peoples of BC, where we live and work to maintain healthy ecosystems for all. All right. So with that, I think we can get started. Willem, if you'd like to.
Yes, okay.
Yeah.
Is that coming through?
Yep, I can see it.
Okay, presenter mode. Hopefully that fills your screen up.
Yeah, that looks perfect.
Okay, well, thank you for having me and for a great introduction, Veronica. I don't need to say anything more, really. Except that perhaps I'm a dad here in Victoria, lucky guy with two kids, house. I enjoy hiking, reading, cooking, mostly the eating part, actually. And so, yeah, just a biologist out here, quite enjoying doing research on a variety of invasive species. And the Lomantria moths are a big one on my plate. So I would welcome interaction from people if they're interested in talking more about them with me. I'll just let the visual soak in here to bring home the title. I'll also point out at the bottom of this slide is a review and synthesis paper recently written by myself and several colleagues involved with Lomantria moth research and management in British Columbia. You're welcome to check that out. It's open access. It also provides a lot more detail than I'll be able to cover here. Most of what you see in the talk is covered in that paper. And all along the way, it presents cited references that are key resources for you to do your own research and follow up. So I invite you to check that out. If the title that you see here doesn't get you to the paper, then certainly the URL address you see tacked onto the end will get you there. And again, it's open access, so it's free for everyone. I should add that this paper takes a conversational tone. You see on the top, it's actually a little blocked from my view, but on yours you see invasion biology, invasion risk, and invasion impacts. I've organized my talk in that manner for message flow. As you might well imagine, the components are actually quite intertwined. So you can consider these as just information pieces that wrap up an entire story. And for that reason, the talk is rather conversational. I hope you find it easy to access. I should also add that while spongy moth is the sort of conventional popular name by which we know Lamantria moth invasions in BC, in particular, since the poster species from the genus Lamantria is in particular widely known as spongy moth. In fact, the risk posed to BC and a lot of the invasion biology that we represent here today is represented across the entire genus. And I've thrown up on the screen a few species that are key players there, not only that pose a threat to North America, that occasionally at least show up on North American shores, for example, at ports of entry. So they do represent a real invasion risk. Um, and I'll just throw in a tidbit of biology that structures how I'll name them. I'll refer to Lamantria dispar as the spongy moth. It's the European form that's highlighted in this world range map in blue, and that for about 150 years has also been established and spreading on the east coast of North America, as you can see in the map. The others are sorted by management groups in North America as the flighted spongy moth complex. In fact, males of all the species can fly quite well, up to several to tens of kilometers in their lifetime. Females cannot universally do so. Most of the Asian forms can, but the European one is particularly well known for being relatively flight incapable, showing either no or just limited flight, which will come back to us in the talk in terms of the invasion risk that is posed by these different species. But for the purposes here, I'm just mentioning because I'll refer to that the Lamantria dispar as spongy moth and the others as the FSMC or the flighted spongy moth complex. So in terms of invasion biology, our story in North America begins in a little town near Boston, Massachusetts, about 150 years ago, where the moth escaped from the home of a private citizen who was attempting to rear them in part for silk production. Um, Little was done over the next decade or two by local management groups, and so the moth unfortunately established and spread irreversibly in Eastern North America. It continues to do so, and you can see a recent map here shows the extent that it has currently reached. Current management operations in Eastern Canada and Northeastern USA are focused on just trying to slow the spread of this now irreversible invasion across the area that you see. Um, I talked a little bit about female flight being a key trait, it affecting the invasion risk that's posed, and we'll visit that a little more in the middle of the talk. But just to cast the biology of this moth group in a visual form for you, showing you a really useful cartoon in terms of how invasions typically unroll. Typically, an invading species arrives somewhere, sometimes on its own, but usually with the help of humans via vehicles and freight. They arrive somewhere, they establish, they spread into available habitat and becomes usually a long-term or even permanent feature. And the reason I've shown you this cartoon as well is to put in parallel on the right side of the slide key traits that help a species be invasion or show greater tendency to successfully invade. Um, and these are aspects of its life history that just make it extra tolerant of the area that it'll be settling in, or perhaps with greater dispersal tendency, a greater propensity to spread throughout new habitat, for example. That's certainly dispersal tendency is certainly a key feature along with wide host breadth that helps Lamantria moths pose an invasion risk to Canada and the rest of North America. So looking at it in terms of the life cycle of Lamantria moths, again, this is not necessarily based on only one. I'm showing you here the spongy moth life cycle, but it's rather similar across the genus. And I'll highlight key invasive traits for you here. A really big one is the fecundity, or the ability to reproduce in this group. Each female in their lifetime, once they mature, they mate and they lay one or more egg masses that can each number into the hundreds or even more of eggs. Those eggs show a pretty typical diapause in natural habitat, but a rather flexible one when it's found in urban settings or in new settings. So that gives these eggs an ability to hatch in unusual new settings, such as invaded habitat. And again, the early part of innovation often starts with transport by human-mediated forms, loosely known as hitchhiking. And these eggs can be deposited on a variety of human-made substrates, so they're ideal candidates for hitchhiking. Hitchhiking is the main means by which the spongy moths originally reached North American shores when they're intercepted on either coast. and by which they've spread throughout northeastern North America since their arrival 150 years ago. Dispersal is another key component, as I mentioned, for an invasion. Partial dispersal capability in this group is shown by instars, particularly the very smallest. They undergo a number of instars, and the very smallest ones are so small that if they let a bit of silken thread loose, then they can be picked up by any wind currents and carried some distance, up to tens of meters or even up to kilometers or more. Typically, it's only within tens of meters or less, and the larger larval forms are limited to movement by foot. So normally on the order of a few meters at most. Far more dispersal potential in the adult form. As I mentioned, the European form, the one we know conventionally as spongy moth, features only dispersal to any distance by males. And so the net population dispersal in the European form by flight is typically quite limited. However, in all of the members of the flighted spongy moth complex, it could be up to tens of kilometers because both females and males can fly. A last invasive trait to point out to you here that particularly orients Lamentia moths towards successful invasion is an incredibly wide host breadth. It's a rather unusual feature of most herbivore insect biology because to be able to defoliate and subsist on the leaves of a host or other tissues of a host, you need to overcome their chemical defenses. It's an unusual feature of Lamentia moths that they seem able to grow, at least for part of their life cycle, on a variety of different hosts, up to the hundreds globally. And I've just shown you a review of the genera that are represented. It was done in 2007. It shores up what total to be hundreds of species globally. We'll revisit host breadth in terms of North American tree species a little later. This is some basics on the population outbreaks, sort of sewing up our invasion biology treatment here, just showing you how the populations exist once they're in North American invaded habitat or in their natural habitat where they originate. They tend to cycle, having population lows and highs. That can have a frequency or a periodicity of every 5 or 10 years, or it can be quite irregular, sometimes lying in latent low basal numbers for years or even decades before outbreak occurs due to perhaps a combination of successful climate and moths arriving in stands of ideal hosts. Those can last anywhere from a few weeks locally to up to years on a regional scale. When they do occur, the populations themselves can outbreak or fall in numbers to basal numbers, but once they're introduced, they tend to be a long-term resident or even a permanent one in new habitat. And the intensity of the outbreaks can be from the trace numbers during population lows to several orders of magnitude higher in larvae. In terms of climate, here we step into the invasion risk. It's just easier to parcel the sort of way you think about the risk they pose here in terms of looking at the risk. Of course, this just reflects aspects of their invasion biology. They show an ability to subsist in climates from the native habitats that you saw in one of my earliest slides to a lot of the North American habitats in terms of the climate that it features. Here are several models that are well respected and quite well done for both the spongy moth on the left and the flighted spongy moth group on the right. All of them showing different currencies for how the models were built in terms of perhaps CO2 or temperature or multi-factor climatic suitability. All of them arriving at similar predictions, as you can see, with red in each of them being high propensity for invasion, showing that most of the US and a lot of central and western Canada that is not currently invaded consist of habitat that would be suitable for invasion were moths of any member of the genus to arrive there. And indeed, they occasionally do, and we manage them for that. So far, invasion hasn't taken over Central or Western North America. But in terms of the rate that we encounter posing that risk, all of the northwestern USA and southwestern Canada do receive occasional invaders. There are also new invaders arriving on eastern shores occasionally. In total, across Canada, that amounts to tens of sites annually. including tens of seaport interceptions that we manage and typically aim to eradicate when they arrive. Again, in the east, we're no longer in an eradication phase in the main invaded area, but outside of that zone, our goal is to eradicate local populations to minimize the spread of that currently invaded area. Here's an example of what incursions look like in BC, taken from 2019 with data kindly provided to me by the CFIA, who oversee a large portion of the trapping program in BC in partnership with the provincial government. In the inset map on the lower right, you see in white all of the rough trap locations across the southern part of the province where the moths pose the greatest invasion risk. These are typically oriented in either key habitat and or along key transportation routes, again, because hitchhiking is a key way in which the moths can spread. And indeed, um, domestic travel east to west in Canada is the key way that moths are introduced to BC from year to year. In blue dots, you can see Lamantria dispar, the spongy moth, and it's not easy to see at this scale, but there was in this year one incursion shown in a brown dot in the Vancouver area of the flighted spongy moth complex. I'll highlight one other point on our graph on the left in terms of numbers observed in British Columbia. It follows an outbreak that occurred in Ontario. It also happened during COVID for both reasons of the outbreak in Ontario and increased domestic travel throughout Canada, mostly by private citizens, but also by, commercial transporters. We had vastly greater numbers showing up in BC shortly following the outbreak period in Ontario. And we see rises and falls that can be explained throughout the previous history that sort of reflect similar ups and downs in terms of outbreaks or transit. Returning to hosts that are affected, but here looking at it on a BC-wide scale, the hosts, again, are many. We have a lot of different tree species here in the province. I just highlight here some prominent for natural forests hosts in terms of broadleaf trees, as well as conifers. And again, it's amazing that this form of moth is known to be able to subsist for at least part of its life cycle, including ability to mature and reproduce on a number of species. So all of the ones that I pointed out here are prominent forest representative species and are on the menu for Lamantria moths. They're sorted in the list, by the way, by family, and then I've shown them by their common name with the genus representing that common name in brackets. And several of the genera on this list are represented by more than one species or variety. Okay, moving on to impacts. Let me just back up here. I shifted into the impact section without noting it, sorry. But here again, I'm just focusing on aspects of the biology, but just really showing what the threat is to BC in terms of the tree species on the menu for this group. The impacts go far further than the actual trees that the moths feed on, as you might well imagine. Again, the population highs during the outbreak phase feature orders of magnitudes in terms of increases in larval numbers, and defoliation can spread from, isolated occurrence or limited defoliation to basically complete defoliation over from small to large areas, as you saw pictured earlier in the talk. And there are, of course, a number of cascading effects that occur as a result of that. On the right, you see the list that you saw earlier in terms of nuts and bolts of how the populations rise and fall, the impacts resulting from the defoliation, the presence of the moths alone, the predators that they affect in terms of predation focus, and all of the cascading results down through the ecosystem are profound. It's very difficult to get a handle on all of these aspects all at once in any one study. And so most of what we know about these impacts are a result of a lot of well-designed, very difficult studies done by ecologists from largely the eastern part of the North American invasion, where we're in a position to actually study how outbreak dynamics affect the local environment. And of course, there are examples from around the world that agree with these results and sort of fortify them. But here I'm just highlighting several studies most of which are cited in the paper I showed you on the first slide of our presentation today, that do a good job of showing the altered biogeochemistry, light, forest structure, hydrology, acidity in the water, and the effects that that has on the species that share the ecosystem with the Lamantria invaders that are affecting it. So again, it's difficult to study more than one or two species at a time. Most studies have focused on target species as indicators of effects. And most of them have documented a whole bunch of associated evidence showing that indeed the more ecosystem-wide factors in terms of biogeochemistry, forest structure tend to go hand in hand with this. As you might well imagine, these are all mechanistically linked to one another. There are also impacts of management, of course. Humans have a huge impact on their habitat. And so well, indeed, the style of management that is chosen for Lamantria moths in North America and in BC is a result partly of evolving availability of techniques, but also consideration of the resources required to implement them, their specificity in terms of the desired outcome. Are we just trying to suppress populations to reasonable levels or slow the spread of a range, as we see in Eastern North America? Or are we trying to gear our treatments toward containment and eradication to prevent, to basically bring the invasion process to a halt? How difficult are these techniques to employ? What are the potential off-target effects that we might want to avoid? And off-target effects are a big one because whether we're choosing silvicultural techniques in terms of forest structure, the order in which we plant things, the species that we plant, or we're using something like a chemical pesticide, whether it's organic or chemical, to control a species quickly. We're interested in finding techniques and treatments that achieve our goals. In BC, the goal is eradication oriented. And what we've arrived at is a globally used product called BTK that you'll hear a lot more about in Camille's talk in a few minutes, that does a really good job when applied in an effective spray manner, as you see pictured on the right, in terms of a ground spray, or even more efficiently as an aerial spray typically, can knock numbers down quickly over small areas before they can spread. So limiting off-target impacts by keeping spray areas to very small ones and avoiding things like having to restructure forest. Also, other off-target effects that are possible by other means are things like biocontrol agents, that is, species from elsewhere in the natural range, typically, of spongy moths that might be introduced to control them, but that occasionally at least either have limited ability to knock them down to eradication or have off-target effects in terms of also affecting other species that co-occur with the invading Lamantria moths. So very complicated question management, all sorts of considerations into the technique we choose. And again, you'll hear more about that in the talk following mine by Camille. I did want to point out a few things that sort of circle back around to points made earlier in terms of management. Public response to local trends in moths or local management techniques have had huge effects on how we manage things. Of course, the government's in place to do year-to-year management of Lamantria moths and an array of other potentially invasive species, and to manage the forest and urban environments that are associated with those as well. Key points in the Lamantria moth North American story that have affected um, the situation we're in now today and our general approach include the original one. It's pictured on the left. This is the invasion near Boston, Massachusetts, 150 years ago, in which I mentioned that government inactivity in the first couple of decades was a big part of why Lamantria was able to establish and initially spread, as you see shown here. It wasn't a species they were used to dealing with. It wasn't a top priority in terms of management. So it actually took some years, including, by the way, a lot of public urging for the government to take notice and attempt a sustained effort. The effort was on and off over the coming decades, and as a result, the middle slide that you see here and that I showed a different version of earlier shows an example of kind of where we are now, basically with an invaded range encompassing most of the Great Lakes. Ontario, this Canada's story in terms of the establishment, the irreversible establishment and spread of spongy moths on our soils, was heavily affected in the early 80s in Ontario, where public outcry against treatment using the BTK spray that I mentioned brought treatments to a halt province-wide over a couple of years. led to an enormous unprecedented invasion that was then impossible to get on top of after, even though the spray program then resumed. So we continue to monitor and to treat the Eastern Canadian invasion. Largely with a combination of pheromone trapping to get a handle on the population numbers and targeted spraying where necessary to limit population numbers and to limit the duration or physical extent of the invasions. But at this point, we're managing essentially a permanent resident in Eastern Canada. We also had a recent example in BC that we did get on top of, luckily. Again, public outcry to do with spraying in the late 90s temporarily brought treatment to a halt, and we saw over a single year spread from local incursions on the order of the size of, say, a yard to a sports playing field to roughly 13 square kilometers of invaded space. And there was an emergency order by the province that brought in treatment following that to get on top of it. Luckily, we avoided permanent establishment at that time. So public engagement has typically been very healthy. It's healthy when the public are engaged. The opinions they take and the effects they have tend to be based on their information, which is sometimes limited and sometimes even misinformed. And so BC's been a great example of continued efforts to get healthy messaging out about our program and provide the right facts to people who are interested to educate themselves on how we manage and what the risks are. This talk is part of that, as is the paper that I showed you at the beginning. I'll drop the citation in again at the end for your reference if you'd like to follow up and sort of find some key resources to do your own research and follow up on the invasion risk impacts and the management techniques that we use in Canada. I just want I want to visit one particular study that was done in PC that was quite useful. It was an economic assessment of the relative benefits of managing moths actively toward an eradication target in BC versus letting them establish and just managing a resident invasion such as we see in Eastern USA and Canada. Um, I won't read you through all of these basic summary points. I'll let you read through them on your own. But it basically found, based on the analysis it did, which was quite conservative, that there were benefits of between 3 to 8 times roughly of trying to keep the moth out of the province and doing the kind of management we're currently doing versus letting them run their course. It was a conservative model in as much as they were only able to easily quantify some of the key costs involved in the invasion, many more that I summarize below in smaller text, and that you can read about all for yourself in Sun et al. 2019 if you care to access that science article. Were left out of the model, and so the model is considered again quite conservative. It seems clear from the analysis that the management practices we're doing are worth the money and worth the good that we do for the environment as a result. I'll finish with a little research that I've done to add to that story. I work with ecology and genetics to forward my research. Here I took samples from across a few years. You can see in the right panel, there's clusters of different colored dots. Each one represents trap returns. It's too difficult to see all of them from this distance, but you generally see clusters of trapping efforts around the province, where in the years shown in the margin on the right, from 2016 to 2019, we had incursions. My genetic analysis just tried to cluster them to show which individuals that were intercepted are related to which others. And the point of this was to get an understanding. Our relatives cluster together physically in space where they show up in the province, indicating that we're successfully containing and eradicating those with our year-to-year treatment efforts, or are they spreading willy-nilly through the province and resulting in secondary invasions seeded or originating from BC locations? And the analysis showed to our delight, that the management program we're using is successfully containing and eradicating most or all incursions on the spot, at least during the time period that you see analyzed here. So a closer look at the clusters, color coding them just as you see on the map, is shown on the left. This is where we're looking at individual by individual pairwise kinship. That is how closely they're related to each other, going from white or very low relatedness to deeper red or very high relatedness. And if you can follow along with the pairwise clustering here, it's color coded in the Y and X axis in the same way that you see on the map. It basically just shows that the clusters, as you would expect, show generally more highly related individuals. The smattering of green clusters you see across the province are simply ones that, with the resolution of genetic data present. We aren't able to cluster easily into separate clusters, but you can see by the kinship values, that they on the left, they basically represent a whole series of much smaller interrelated individuals, all showing that these invasions tend to represent unique invasions from outside of BC rather than ones that are reseeding one another within BC. And the conclusion from that is the management techniques we're using are successfully containing these incursions and ultimately eradicating them. Here are two examples that we were able to document by the time I made the presentation. Eradication of a long-term, that is multi-year invasion in Comox from 2016 to 2019, with eradication that is no more detections by our trapping program as of 2019. And a similar story in Surrey. That was a much longer term, much larger invasion that we were very happy to get on top of after a series of years of combined trapping and various spray efforts. I won't read through the conclusions here. All the bullet points here go through content that I've covered. Again, I'll draw your attention to a reference that presents a lot of the same material, but in greater detail and with cited references for your inspection. That's listed at the bottom. Again, it's open access. I encourage you to access it and read it, and get in touch with your government to learn more. Thank you.
Thank you so much for a wonderful presentation. I really, really enjoyed seeing, well, enjoyed is not really the word, but just the ecosystem-wide impact. I think that's something that sometimes we forget to think about, that big picture
Yeah,
and how everything is sort of connected at the end. So yeah, thank you so much, Willem.
thank you.
Um, if I believe we do have a question, I will, if you have a question, please feel free to raise your hand or put it in the chat. We have a question here. It says, thanks for your presentation, Willem. Need to see the results from your recent BC population genetics work. Any plans to look at the relatedness of moths trapped in BC to elsewhere in Canada or the US?
Yes, that's a key point. We pursue that partially through molecular tests and partially through morphological inspection. That is, our trapping program brings back hundreds of moths per year, or thousands actually, from across Canada. Each one of those is inspected and identified to the species level that you saw covered in this talk. We do have occasional incursions by various species, as I said, from across the Lamantria group. Lamantria dispar is by far our biggest customer in BC, simply because it's established, as you saw, in Eastern North America, and it's mostly by domestic travel, by commercial and private vehicles and their cargo that bring them to the West. And so those are the ones we mainly encounter. But for example, in the map I showed you from 2019, we do have occasional incursions of the rest of the flighted spongy moth complex, and we've luckily been able to detect and eradicate them in BC so far.
So thank you. Another question is, what is something you'd want to share to policymakers or decision makers for future years?
You know, the biggest challenge ongoing, government is formed by and for the people, as you well know. Our government does a great job of representing that. We're in a great country where people can sort of vote and lobby for their governments and expect to get results. I showed you at various points in the talk evidence that that's the case, of course. I'm sure you have many others. But it's really hard to keep information current. This is a multimodal world now in terms of information that allows so many channels for information. It's difficult to know the best one to approach the public. There are also, these channels are also unfortunately also available to people that might be interested in spreading information, passionate about an issue, but less well informed about the biology that I just tried to show you. So for policymakers, I would just say that trying to get information to the public is going to always be an ongoing priority. And as I mentioned, I think the BC government does a great job in that for Spongy Moth. CFIA has had some role, but the Spongy Moth page, hosted by the province of British Columbia out of the Ministry of Forests, has done a super job of keeping year-to-year management updates available. They put out postcard campaigns approaching and right up to any spray programs that are required. For example, in the last year, only two were. In other years, we've been much busier at multiple sites, as you saw, for example, in 2019. This year, there were only two in Delta and Squamish. So information campaigns in terms of advertisements where possible, postcard sendouts, hosting a hotline for people with concerns, and hosting a website reporting the planned spraying and then the results of that spray have just been great ways to get that messaging out there. So hopefully you appreciate some of the information we're giving to you. This review and this talk today are all part of that. And so I really think that's an ongoing imperative.
Mhm. Absolutely. And we also have Johan, if you would like to ask your question.
It's fine. It was a problem at my end with the speaker. It's solved. Thank you.
Okay, no problem. And then also in the chat, we have Tracy wants to confirm that in your last slides, you demonstrate that the detections are all unique.
If I understand you correctly, I think you were referring to my point where I was saying the incursions we detected were mostly unique. And yes, that's largely the case. I tried in the limited time to explain that the green cluster of all the colors that I showed you, you saw that it was sort of smattered across the landscape on the right. That reflects the limit of our clustering model based on the available genetic data. But the kinship analysis was much more useful, and that's why I showed it to you, even though it's unfortunately a little difficult to interpret when you first encounter it. That shows you these smaller clusters that comprise that green cluster. And so it suggests that with the information that you saw there, yes, most of them are unique. I can't guarantee that every last one of them is, but certainly the larger ones we saw, for example, Comox, Surrey, one or two other areas, and the vast majority of the green ones you saw across the landscape seem to reflect independent incursions. That is, individual clusters that aren't related to nearby ones on the landscape. And that suggests that our ability to detect them, contain them, and eradicate them has, for the years that I showed you, been successful. And by the way, those were heavy years. Those were some, as I said earlier in the talk, 2016 to 19 was leading up to some of the heavier numbers of incursions across the province. So despite that added traffic that we were needed to deal with, it turns out that for those years at least, we were very successful at doing so. So that bodes very well for our management program in general.
Thank you so much. All right, I think that concludes our period of questions. If you do have any more questions for Willem, please feel free to put them in the chat or reach out to us after this presentation. All right, so we will welcome Camille. If you're ready to share your screen.
Sorry, 1 second.
Yeah, no worries.
Okay, thanks, Veronica, and thanks, Willem, for a great presentation. I'm going to be covering prevention and reporting of spongy moths. So I'm just going to quickly go through some of these little intro slides here since it was covered pretty well by Willem's presentation. So spongy moths are a federally regulated pest species. They're listed as a provincial EDRR species on the Government of BC's Priority Invasive Species list. That's early detection, rapid response, meaning it's considered a high risk to BC and has a management objective to eradicate. The key events here for the introduction of spongy moth started around the early 1900s when it was first detected in BC. And then since then, repeated introductions have been found, especially in urban areas, leading to ongoing monitoring and control efforts. Today, detections mostly occur in southern urban centers where new introductions are most common. And when detections increase, treatments are sometimes necessary to prevent establishments. You can see in this little timeline here, the gray bars here are the number of moths detected, and the red line is the treated area following the detections. Some of the impacts of spongy moth we talked about already. Environmental impacts. They alter the natural and urban landscapes where they become established, and in severe outbreaks, spongy moth caterpillars can strip entire forests of their leaves. You can see in this photo here a severely defoliated patch of trees. For example, in Ontario alone, over 1.8 million hectares of forests were defoliated in 2021. This massive loss of foliage weakens the trees, reduces seed production, limits regrowth, and makes them more vulnerable to diseases, pests, and harsh environmental conditions. And then over time, this can lead to widespread tree death, which can then cause wildlife to lose food and habitat, and forests can permanently change in composition, even affecting the plants growing in the understory. Some more images here of some severe defoliation. There's also economic impacts of spongy moth. In BC, widespread infestations could seriously impact the forest sector and related industries due to the types of trees that spongy moth defoliates that Willem mentioned before. Spongy moth can reduce the attractiveness of private property, reduce the market values, and defoliated trees in urban areas impose high costs for tree removal and replacement and reduce the attractiveness of public areas. For example, in that 2021 infestation in Ontario that affected 1.77 million hectares, it had major economic impacts. The tree, fruit, and blueberry crops were damaged, pest control costs increased, and the value of woodlots declined. And spongy moth may impact perennial agricultural crops like nursery and tree fruits and berries as well. There's also some social implications. The hairs on the caterpillars can cause skin irritation in some people. Damage to forest ecosystems can impact recreation. And when they defoliate the trees, it thins the canopies, which can degrade the aesthetic value and ecosystem function of the trees. So moving on to prevention. Integrated pest management. To manage the impacts, we need a framework that protects assets, minimizes risk, uses resources efficiently, and supports long-term resilience. So integrated pest management, or IPM, addresses these impacts in a science-based approach that uses multiple strategies to prevent and manage pests in a way that's environmentally, socially, and economically sustainable. It focuses first on prevention, not just treatment, uses multiple tools to treat and prevent invasive species, not just chemicals or pesticides. It's based on monitoring, thresholds, and evidence, and aims to minimize harm to ecosystems, people, and non-target species. So you can take a look at the invasion curve here. This illustrates the relationship between the time of introduction of an invasive species, the area they invade, and the associated control costs. So it's divided into 4 stages here. The first stage on the far left is the prevention stage, and this is where we have the most power to act against a new invasive species. By preventing the introduction, we can save significant resources and avoid a range of negative impacts on ecosystems, economies, and community health. If an invasive species is allowed to establish, we move into the eradication stage, and this comes with increasing costs and is usually less effective. So the longer that we wait, the more entrenched these species become, leading us to the containment stage, which aims to limit their spread. And both these stages can strain local resources and impact our natural environments. And then finally, we get to long-term management, which is the most resource-intensive stage, diverting efforts that could be used for other community needs. So by prioritizing prevention, we can mitigate these impacts before they escalate. Again, here's prevention is the most effective and least costly strategy. We can all play a part in this by following some of these Behavior programs, you might have heard of Buy Local, Burn Local, which encourages people to buy firewood in the place that they'll be burning it and not transport firewood around, which can be a vector for invasive species to move to new locations. Play Clean Go by cleaning your outdoors equipment, inspect your outdoor items, which can be a way for invasive species like spongy moth to spread if they're attached to your equipment. Okay, so moving on to monitoring. When spongy moth is detected in BC, the BC Plant Protection Advisory Council evaluates and provides recommendations on how to follow up with new incursions. Further surveillance or eradication, if there is evidence of successful local establishment, are typical courses of action. The CFA undertakes surveillance annually to monitor for spongy moth across the province using pheromone traps. Those are these little green traps here. You might see them hanging from bushes or trees. They contain a spongy moth pheromone inside. And then the surveillance data gathered is evaluated by the Plant Protection Advisory Council, their technical advisory committee, and then that informs where the treatments will occur. So mentioned before, the most common treatment option used worldwide is Bacillus thuringiensis. You might hear it called BT, or the subspecies variety BTK is most common. It's a naturally occurring bacteria that's found in soil and plants, and BTK's most appropriate treatment in areas with confirmed spongy moth infestation. It's applied by trained and certified applicators, and it can be applied aerially, like in this photo here with the airplane, or it can be applied on the ground level with hydraulic sprayers directly applied to the vegetation that's consumed by spongy moth caterpillars. BTK only affects the larval stages of susceptible insects. It can't be used to kill the eggs, pupa, or adults. And to work, it must be eaten by the caterpillar. It won't harm the caterpillars if it's only on their skin. It has to be digested by them. And once it's inside the digestive system, the bacteria multiplies and releases toxic substances, and the caterpillar's gut is paralyzed, so it stops feeding on the foliage and it dies within 1 to 5 days. Larvae are most susceptible to BTK when they're in their early developmental stages. BTK poses a low risk to humans, other mammals, plants, birds, fish, honeybees, or other beneficial insects, and only targets the caterpillars of the moth and butterfly species. It's an effective treatment, so after several decades of use, aerial sprays have been proven to be highly effective for controlling spongy moth. It can be applied very quickly. Large areas can be treated in just a few hours, and most droplets will have reached the ground within 10 minutes of application. It's very thorough. It can be used to treat remote or difficult to access areas and provide even coverage throughout the target area. And most important, the droplets can penetrate the crowns of even the tallest trees. And it's also cost effective. Aerial application has the lowest cost per hectare of any effective treatment. Moving on to reporting here, it's important to know how to identify all the life stages of spongy moth so that you can report potential findings at any life stage. The adult spongy moth or caterpillar might be the most recognizable or common image to see, but it's important to be able to recognize their egg masses as well, since that's the most common way for new infestations to spread. And spongy moth has a 1-year life cycle. Egg masses overwinter, and then in the spring, when temperatures become warm enough, the eggs will hatch and juvenile caterpillars will ascend the trees to feed on foliage. They'll then pupate and emerge as adult moths to lay eggs and repeat the cycle again. Here's some photos of the egg masses on some outdoors equipment and on a wheel of a car here. The eggs are usually laid on a flat surface, such as a tree trunk or on the side of a building. They're a little beige spongy mass that measures about 3 to 6 centimeters long and 2 to 3 centimeters wide. They appear fuzzy with tiny hairs. Since the female moths don't fly, they lay egg masses close to where they emerge from their pupa, and each egg mass can contain up to 1,000 eggs. Here's another image of an egg mass on some tree bark. It's important to check firewood, camping gear, vehicles, trailers, RVs, and outdoor household items like patio furniture, potted plants, lawn ornaments, even birdhouses for spongy moth egg masses. Any outdoor household items can potentially be a source of egg masses. And since young caterpillars can only drift very short distances on the wind and female moths can't fly, spread is largely attributed to human movement of egg masses. Moving on to the larval stage. Spongy moth larvae or caterpillars have 6 larval instars. These are the larval life stages. When they're first hatched, they appear hairy, black, and brown, and are approximately 3 to 5 millimeters long, so pretty small. Mature caterpillars appear hairy and are up to 6 centimeters long, so this is a more mature one on the right here. They have 5 pairs of blue and 6 pairs of red spots going down their back. They're voracious feeders, and one caterpillar can consume up to 100 square centimeters of foliage. As they grow, their feeding rates increase, and so does the defoliation of trees. So this is the life stage where they do damage by feeding on the foliage of trees, which can then lead to tree mortality. And feeding occurs initially during the day and then at night as the caterpillars mature. Here are some images of the spongy moth pupa. Larvae seek sheltered areas to pupate. Pupa can be found anywhere the mature caterpillar chooses as its final hiding spot, including branches, tree trunks, or rocks. Then by midsummer, the caterpillars pupate and emerge as adult moths. And here are some images of the adult moths. We have a female moth on the left in this image and a male on the right. Female moths are larger with a 5-centimeter wingspan, white wings that feature a dark zigzag pattern across the midsection, and yellow to white hair on their head and thorax. The European subspecies of females cannot fly. Males are significantly smaller with a 2.5-centimeter wingspan, brown wings, brown hair on their head and thorax, and feathery antennae. Both the male and female spongy moth are characterized by a chevron, it's this little V shape here on the wings, and it points to a dot pattern on their wings. So this is one of the main identifying features of how you can tell spongy moth from other moths. If you do spot a spongy moth, don't handle it without the gloves. As mentioned, the hairs can be irritating for some people's skin at any life stage and can cause allergic reactions. Make sure you take photos of the specimen you find. Try to take a close-up focused photo from multiple angles to get the best chance of a proper identification. Take a top-down photo, take photos from the side, from the front. Will be the best chance of getting an accurate ID. And if you can trap the specimen in a jar or a Tupperware or something while you await confirmation of the ID, that's the best thing to do. There are a few different ways to report your sightings if you think you might have found a spongy moth. There's this app that you can download, Report Invasives, available for Apple and Android. You can find in the App Store. You can upload your photos there and submit a report. You can also use the app iNaturalist. It will give you an immediate ID of what you're looking at. If you're curious of what you're looking at, maybe for an initial ID. And then if you do think you found a spongy moth, you can report it using the ISCBC website. You can email us at info@bcinvasives.ca, or you can call this hotline to report what you found. Okay, so that's the end of the presentation. And if there are any questions for me or for Willem, we have some time here for questions.
Thank you so much, Camille. That was a great presentation. It's always shocking to see where the egg masses can be found, like on the wheels of a vehicle. Like they definitely find ways to move around.
Yeah,
All right.
exactly.
Johan, do you have a question for Camille?
Hi, I have a comment. I have had very bad experiences with the aerial spraying, not personally, but in my environment. I used to be organic farmer in Matrosen. And in 1999, my farm got sprayed. And as a consequence, all formerly uh, abundant Lepidoptera, like uh, pine whites and what are the others called? Skippers, all disappeared. And only it took 3 years for them to reappear very, very slowly. And I wonder if these moths are so rare, aren't there other methods to detect and eliminate them than aerial spraying, which covers large areas and basically eradicates all Lepidoptera which are feeding on vegetation? uh, isn't it possible if these males are caught in pheromone-baited traps to concentrate on these males and eliminate them?
Yeah, sorry to hear about what happened to your farm. It's definitely a balance, I guess, of the impacts of the treatment versus um, the positives in what it can do to control the population from spreading. Um, I think you mentioned the pheromone traps, I believe, are more so for detection to find out where the moths are present rather than to control the species. As far as I know, the BTK is the most effective treatment against spongy moth. Unfortunately, I don't think there is really another option other than treating with that that's effective for these large areas. But if there's somebody else, I don't know, will let me know of alternative options beyond BTK.
Yeah, can you still hear me all right?
Yeah.
Okay.
Yes.
Yeah, your observations, Jochen, thank you for those. They touch on a number of points, all of which are taken into consideration for the management in general. As an overarching response before a few more details, I would say that we're trying to identify the safest, most resource efficient, and basically effective treatment available to us. And so that's a very broad issue, but all that to say that yes, BTK does affect a variety, many lepidopterans, provided that they encounter it at the right moment in their life cycle, whether ingesting it off of leaves, for example. The phenology or the annual pattern of the life cycle of Lymantria moths is not identical to all other local lepidopterans, but you're absolutely right. For those that happen to have larvae feeding on foliage, they'll be at risk of being killed, just like the Lymantria moths that we're trying to treat. What we try and do with our trapping program that you saw in one or two maps on my presentation are to firstly identify areas that need spraying at all versus just need monitoring. When we first detect them, typically we respond not with spray, but with more intensive pheromone trapping, which speaks to your suggestion that we could use the traps to control the populations. It is possible that, in principle, that a mass trapping effort can reduce population numbers and in some cases possibly even eradicate it. But the resources required and the logistics associated with implementing a mass trapping program for example, every case that you saw on the landscape in a couple of my example slides, it's simply out of the question in terms of the resources required, the humans required to deploy them, the number of traps that we then have to monitor, and with no guarantee that we're actually going to eradicate because we're in an eradication mode rather than a population suppression mode or containment mode, as Camille used the wording of. In BC, we're trying to go in and out as efficiently as we can and over very small areas, actually, the minimal possible, treat an area that's going to reduce the population and eradicate it permanently. Of course, from year to year, in some areas, unfortunately, you have repeated incursions from possibly, and my analyses suggest on genetics terms from the same origin from some distant location. So it's possible that despite spray programs, when we deem them necessary for lingering incursions, we can have to treat an area over one or a few years. Typically, that's the maximum we need to bring a population down to zero. And following our spraying, by the way, we do monitor that result by continuing our trapping in terms of deploying pheromone traps over the landscape where we have treated as well as surrounding areas to gauge the success of our methods. So the best I can do within the time constraints here to answer you is we're using the safest treatment possible, the most taxonomic specific one possible, that is BTK, focused on lepidopterans, but at least not harmful to other organisms, including mammals like humans. We're doing it over the minimum area possible that is nonetheless guaranteed to contain the population. So, for example, on the scale of your farm, something like that, we would take account of all sorts of surrounding aspects of the environment, but basically aim to contain any detection that might have been found on a farm such as yours or in the vicinity. Yes, the research does show, as your observations did, that the immediate aftermath, it certainly shows, not for all lepidopterans by any stretch, but certainly key players in the local environment, that they are reduced in numbers. We do see the typical recovery over a series of months or years that you observed in your area. And what we hope by targeting sprays over as small an area as possible, that we will eventually see the kind of recovery you observe, that is dispersal from the surrounding area that is not treated into the areas that were affected by the treatment. This is basically, as Camille suggested, the best approach that we've been able to assemble and that has proven to be successful over the years to minimally impact natural forest species in terms of plants and animals, while removing the drastic ecological consequences that would result from the establishment of Lomantria moths in your area.
Thank you so much, Willem. And just to wrap it up, we will just address one last question. It says, beyond reporting, what could be done to control egg masses if they are discovered?
If you personally discover an egg mass, subject to the kind of precautions that you heard in Camille's talks, it's possible to remove them. And this partially responds to another of the many aspects that Jochen brought up in his previous question. They can be found basically at any part of the environment. It's quite hard to do a thorough survey, although egg mass surveys are done in the eastern part of the invaded range. If you were to simply find one, you can remove it. And in fact, occasionally, under certain circumstances with very low anticipated egg mass numbers and easy site access, it has been possible for managers to go in and survey for egg masses, but they can be found anywhere from the ground up to upper canopy and in a variety of settings, both natural and human-made. So it's very hard to implement an effective, thorough survey for egg masses entirely. But if you happen upon one, yes, they can be removed.
Thank you so much. Once again, thank you to both of you for your wonderful presentations. It's always good to learn as much as we can about these invasive insects, their impacts, and obviously a lot of things that we can personally do to prevent the spread. There are also different ways of reporting. If you do have more questions for Camille, for Willem, or any general questions about spongy moth, please feel free to reach out to us. And once again, thank you for joining us. Thank you for the presentations, and Thank you for wanting to learn more.
Thank you.